Hello everyone. We are honored to present this modest research paper entitled Finite Element Programming of the Damage Model for Composite Structures. The finite element program presented in the study is taken from the book Finite Elements in Plasticity, Theory and Practice by Owen and Hinton. Its distinctive feature is that it uses the Newton-Raphson method, replacing tangential stiffness with secant stiffness, which prevents divergence of the response at break or rebound points. It is based on the principle that a sufficiently small scale all materials are heterogeneous, even those commonly referred to as homogeneous. However, when designing a microscopic structure, the scale is so large that a statistical average of the microscopic properties can be observed, and the continuity of the materials can be assumed. Once this assumption is accepted, the concept of homogeneity is deduced. Rely on the theory of continuous mechanics, it is necessary to replace the real material with an effective homogeneous equivalent material, such that at the square of the structure study, the fields of structure and strain are macroscopically the same in real and homogeneous structures. Therefore, a new model has been proposed and introduced in finite element code to describe the nonlinear behavior of concrete and reinforced concrete under metric loading. See the model of Smahi and Boeuf 2024, briefing the principles of damage mechanics and the concept of fracture mechanics while using foundation of the continuous mechanics of materials. The nonlinear behavior of composite materials by the finite elements method. The Newton-Raphson method is generally fast and efficient, allowing linearization of the equilibrium equation to obtain an iterative solution. For this reason, and in order to provide a solid basis for a more efficient iterative strategy, in a model of Smahi and Boeuf, they opt for the Newton-Raphson method, which will be modified by replacing the tangent stiffness by a secant. The loading is then applied in increments, and solution in each step is obtained iteratively until equilibrium is satisfied at a given accuracy. The iterative processes of the two methods are the same, and the tangent stiffness must be replaced by a secant. See the equation 1, 2, 3, and 4, and the figures 1 and 2, which illustrate the two methods, tangential and secant. In order to apply the finite element method, it is first necessary to perform a geometric discretization or meshing of the structural elements, see figure 3, taking into account the boundary conditions. To do this, we define the following for each elementary volume: like a stress vector, a strain vector, the intensity of the damage defined by the variability. Finally, the finite element method is applied where the elasticity matrix is affected by the secant Young modulus and secant Poisson's ratio. See equation 5, 6, 7, and 8. While equations 9, 10, and 11 show that the equivalent elasticity matrix varies depending on whether we are in a state of plane stress or plane strain or for axisymmetric solids. A graphical interface was added JADE 15.03. A finite element was developed and modifications were made to the subroutines float, flowpool, mode base, residue, and output. See figure 4. Example of program application. The proposed finite element program was applied to a three-point bending beam, see Figure 5. We evaluate the effectiveness of the proposed model and code for the study of the nonlinear behavior of the concrete structures under static and monolithic loading, comparison with some selected codes where simulation results are very close to the experimental results, show that the developed numerical model is very efficient compared to the ANSYS and ESA codes, while the results obtained by the Aster code are far from the experimental results. See Figure 6. In conclusion, we can say that the computational program was developed based on the subroutines of the finite element software developed by Owen and Hinton. And the new model is introduced based on damage mechanics, the model of Smahi and possesses the replacement of the tangent stiffness by the sequence stiffness. The proposed model for concrete and reinforced concrete structures under static and monolithic loading are damage variables affecting the mechanical characteristic of the homogeneous material is developed based on the behavior laws of concrete and steel, while applying the other theories, namely the mechanics of continuous mechanics and fracture mechanics. This elaborated program allows us to determine the localization of deformations, the constraints and their directions, and the variation in the mechanical characteristic on the considered solid in the nonlinear domain. By linking this the pre- and the post-graphic processor, this allowed us to follow the real behavior of the structure's composite until a rupture. Finally, we hope that this contribution will add value to the conference and that it will have met some of the objectives set. Thank you for giving me the opportunity to be among the contributors, and thank you also for listening and for your attention.